manipulating the ideal gas law. Sometimes we need molar mass or density, in which case, using the rearranged gas law equation, mm equals dirt over P, it makes your life easier without having to rearrange each time. To remember your equation, you can think molar mass. So if you just put 1m, it makes more sense. The molecular kitty cat puts dirt over its P. So dirt over P equals molar mass. Molar mass, remember, has the units of grams per mole. And density in these problems will be grams per liter. So in this first problem, I know I'm going to use the rearranged equation because it's talking about density. So I know density, I know pressure, I know temperature. Notice I know one of everything, but they have density instead of moles or mass. So we write our equation. And just like we've done before, we have to rearrange. But in this case, it says, what is the molar mass? Since I'm looking for that, I don't need to rearrange in this case. So I can start plugging in. Notice that density has 2 units, grams over liters. So wherever density is where the number in grams goes. Liters will always go opposite of it. If they gave you the grams and the liters, you could just plug the grams in on top and the liters in on bottom, and that would be the density. R, just like we saw previously, 0.0821 liters times atmospheres goes on top, mole times Kelvin on bottom. Temperature and pressure from the top is 755 torr. I know my pressures aren't going to cancel, so I'm going to go ahead and convert that toward ATM. 1 ATM is 760 torr. Cancel, make sure that I didn't miss anything. The only things I have left are grams and moles, and those are the units per molar mass. There should be no reason for you not to know the units per molar mass, because if you cancel everything, that's what you're going to be left with. In the calculator, I get this. Looking up at the problem, I want 3 significant figures. So 45.0 grams per mole. One more together. This one says, what would be the density of oxygen gas at 70 degrees and 3 ATM? So I see density, so I know I'm going to be using this equation. But they didn't give me molar mass. A lot of times the problem will not give you molar mass because they give you what your substance is. Because I know I have oxygen gas, I know oxygen gas is diatomic, so I can find the molar mass from the periodic table. 16 times 2 is 32 grams per mole. And that's my molar mass. So for your molar mass, always find the substance and write the formula if the formula wasn't given. And then look on the periodic table to find your mass. So in this problem, they want to know density. So we will need to rearrange the equation. So I multiply by P. And then divide by RT. So I have P times MM. Get rid of RT. So density is equal to pressure times molar mass over RT. Molar mass has 2 units. So one unit's on top, the other unit's on bottom. You should never put a slash on your dimensional analysis table. This line is the slash. R needs to go on bottom. And temperature needs to go on bottom. Cancel my units. I'm left with grams over liters. Density has 2 units, just like molar mass, so those are the units. You get this in the calculator. Again, make sure you can get that. We want 2 significant figures, so 3.4. Go ahead and pause the video and try this one on your own. Restart when you have a final answer. So molar mass times P over RT. So sulfur dioxide is SO2. Your molar mass should have been 64.06 grams per mole. Our rearranged equation was just like the previous one, molar mass times pressure over RT. And then we plug it all in. Make sure that you converted your torr to ATM if you did not get that answer. So 4.77 grams per liter. This problem is a little bit different because they didn't give you the density. They did give you, though, the mass and the volume. So you have 2 options. You can either calculate the density and then plug the density into your equation, or you can plug the grams and liters into their respective spots in the FLM or dimensional analysis table. Choose whichever way you want. Restart the video when you have a final answer. All right, so on this problem, we were using molar mass equals delta over P. The writing in black is if you chosen to find density. So when I found density, I got 2.85714 grams per liter, and then I plugged my density into my equation. If you're breaking up a problem like I did here, make sure you keep extra sig figs. That's why I have so many numbers after the decimal instead of just rounding it to 3 sig figs. Plugging everything in, I get 38 grams per mole in the correct number of sig figs, which is 2 based on my pressure. The other option is down in blue. I could just take my mass and my volume, because that's what density is, mass over volume, and plug it in. Notice I get the same answer, I just don't break up the problem. So whichever way you want to do it is fine. But again, if you break up the problem, you need to keep extra numbers so your answer is the same as the non-rounded answer in blue.